Durable press cotton fabrics are treated to improve their recovery from wrinkles after washing. Wrinkle recovery angle measures how well a fabric recovers from wrinkles. Higher is better. We're given data on the wrinkle recovery angle in degrees for the same fabric discussed in a previous exercise. The fabrics are Permafresh and Highlight. The manufacturer wants to know how large the difference is in mean recovery angle. So we're going to calculate a number of things in this problem. Okay, we're going to do the mean and standard deviation for Permafresh, the mean and standard deviation for Highlight. Then we're also going to do the standard error, the critical value for a confidence interval of 99%, and then we're going to construct a 99% confidence interval using all those calculations that we have done. So let's start with the mean and standard deviation for Permafresh and Highlight. Okay, so the mean for Permafresh and the mean for Highlight. We are going to calculate both of those on the calculator. So we'll do an X bar and an S for both of those on our calculator. And we will do that by entering the data into lists. So we'll go to our calculator and we're going to go to list 1, and I'm going to clear out data that's already in my calculator. You often are going to have to do that to enter new data. And I'm going to enter the data for Permafresh and for Highlight. So here I have entered the data for Permafresh into list 1 and the information for Highlight into list 2. So I'll quit out of my lists. And now I want to calculate one variable statistics for each of them. So I'll go to one var stats. Remember, the default is list 1. So to get Permafresh, I'm just going to go ahead and hit enter. And I get an X bar of 129.6. And I get an S of, and I'm going to round this to, I'm going to round this to 17.743. So there is my data over here for Permafresh. For Highlight, I'm going to do the same thing with the one variable stats. Stat over to calc, one var stats, but now I have to ask it to do list 2. So I'll do second and list 2. And I'll hit enter. And from that, I will get an X bar of 171.25 and an S of 21.453. That's the first part of the problem. It asked me to find the mean and standard deviation for Permafresh and the mean and standard deviation for Highlight. The next part of the problem is asking me to find the standard error. And the formula for standard error is going to be the square root of S1 squared over N1 plus S2 squared over N2. And what do we have for those values? Well, we have the square root of 17.743 squared over, the n on that one was 5, plus the 21.453 squared, and the n on that one was 4. So if we go ahead over to our calculator and pump those numbers in, we're going to get, I'm going to do the 17.743 squared. And then I'm going to divide that by 5. Okay. And I'm going to add to that 21.453 squared divided by 4. And then I'm going to take the square root of all that, the square root of my answer, and I'm going to get 13.342. So our standard error is 13.342. The next thing that it's asking me to find, we go back to the problem, we can look and we can see the next thing it's asking me to find, found the standard error, is the critical value for a confidence interval of 99%. So to do that, I'm going to go to my calculator. So I'm looking for T star for 99%. And we're going to go to the calculator for that, and we'll clear all this out. And what we're going to use to do that is the inverse T function. And that's on the distribution menu, number 4. And we want to put in the first value that we're going to put in is the area to the left of our critical value, 0.995 for a 99% one. And the degrees of freedom. We're going to use the conservative option 2, which tells us to take the smaller of our sample sizes, smaller one is 4, and subtract 1. So our degrees of freedom here are going to be 3. We'll enter that into the calculator, and it comes back with 5.841 when we round it. So our critical value, our T star, is 5.841. Now the last step here is to actually construct our confidence interval at 99%. The way we're going to do that is we will do x bar 1 minus x bar 2 plus or minus T star times the standard error that we found. And now we're just going to plug numbers in. So this will be 129.6 minus 171.25 plus or minus 5.841 times 13.342. And we will go ahead and do that on the calculator. So when we do 129.6 minus 171.25, we get a value of negative 41.65. That'll be plus or minus, and then we have to multiply our critical value by our standard error, and that was 5.841 times 13.342. And when we do that, we get 77.930622. So here we have the numbers to construct our confidence interval, and then we'll go ahead and do those calculations so we can have a confidence interval here, rounded to 3 places. So we will take negative 41.65, and we will subtract 77.930622, and we will get negative 119.581. Negative 119.581. That's one end of our confidence interval. To get the other end, we're going to take the negative 41.65 and we will add the 77.930,622. And when we do that, we will get 36.281 when we round to 3 decimal places. So the final part of our question is to construct a confidence interval at 99%, and there it is, negative 119.581 to 36.281.